Hey y'all, it's me, Miss B. Today we are talking about rational functions and their graphs, okay? And the major thing today is going to be how to find the asymptotes and graph them. So first we're going to start with vertical asymptotes. So vertical asymptotes are found at values of x that make the denominator equal 0. And that's when it's been simplified, okay? And so the graph is never going to cross a vertical asymptote. This is something it might look like. You might have a graph like this, and then it might look something where you have that's your asymptote, and so it might get really close to it and approach it, but it's never gonna touch it. Okay, so this is kind of going along with our domain notes. So what we're going to do is we're going to set that x plus 1 not equal to 0 because we don't have a denominator, so then x is not equal to -1. However, so this would be like the domain. However, we would have a vertical asymptote at x equals -1. Okay, so if you simplify a rational function, it's going to give you a hole instead. So it might look like it's an asymptote, but it's actually just a hole in the function. So just make note that this would not be an asymptote. All right, and your graph might look something like this, where you have that, and it would look, oopsie daisies. So it might look like it goes from here to here and then continues on. So it has a little hole right there. Okay, so like that might look like y equals x plus 1 times x plus 5 over x plus 3 times x plus 5. And these two things cancel out, and so there's a hole there, but not a asymptote. So it still doesn't exist for the graph, but it's a hole. All right, so let's go ahead and talk about finding the vertical asymptote. Like I said before, you're going to factor and solve or set the denominator equal to 0. So we're going to do, for this one, 4x minus 8 is equal to 0. Remember, we're finding the vertical asymptote, not the domain. So we add 8 to both sides, and we get 4x equals 8. So then x equals 2 is our vertical asymptote. We do have to have an equation there. All right, so then for this next one, we're going to set 2x squared minus 5x minus 3 equal to 0. We are increasing our rigor on factoring here, so make sure you review that if you don't know how to do it. I need two numbers that multiply to be -6 because I have to multiply my 2 and my -3. My s is going to be -5, and my two numbers I end up having are -6 and +1. So what I'm going to do is I'm going to split the middle, so I have 2x squared minus 6x plus 1x minus 3. And then group these two together, and find the GCF of both of those. So I'm going to factor out the 2x from this, and then I divide it out, so then I'm left with x minus 3. This one I factor out just a 1, and I'm left with x minus 3. Because I got an x minus 3 and an x minus 3, I know I did it correctly. So then I can write this as x minus 3 times 2x plus 1. Then using the ZPP, zero product property, I split this into x minus 3 equals 0, 2x plus 1 equals 0, and solve. So I get x equals 3 and x equals -1/2. So those are two vertical asymptotes for one graph. All right, next up we want to talk about slant asymptotes. So in a rational function, if the degree of the numerator is exactly 1 more than the denominator, the graph is going to have a slant asymptote. Okay, I'm just going to make a note that it can have a slant and vertical asymptote. Okay, so you can have both. All right, to find the equation, you're going to divide the numerator by the denominator. And the equation is going to be the quotient excluding the remainder. So it ends up being the graph of a line. All right, so here's an example of that. So we're going to take our numerator and divide it by our denominator. So we have x minus 3 divided by 4x squared plus 7. I'm actually going to use synthetic because I think it's easier. So I'm going to do x minus 3 equals 0. So x equals 3. And then don't forget your x. So we have 4, 0, and 7 because this takes the place of our x squared. Okay, so we're going to drop this down. Get 4. 4 times 3 is 12. Add, we get 12. Multiply by 3, we get 36, which gives us 43 is our remainder. Remember, we don't really care about our remainder, so we're just going to write the equation of this line. So it's going to end up being y equals 4x plus 12. So this is the graph of our slant asymptote. So we also have an asymptote at x equals 3. So I'm going to go ahead and graph kind of an idea of what this would look like. So we would have, I don't know what I'm doing here. Jeez. All right, and then we have to go plus 12. That's kind of rough. 1, 2, 3, 4, 5, 6. So every 2 will be, this will go 2, 4, and this will go 2, 4. Okay, so we have 4x plus 12. So here's 1, 2, 3, 4, or here's 4. And I'm not doing this right. Here's 12, 4, 6, 8, 10, 12. And then our slope is 4, so we're going to go 2 over 1. There's our slope. So I'm going to go ahead and draw a dashed line for that. Starting here. So there's our slant asymptote. It's kind of a rough picture, but we get the general idea. And then we want to graph x equals 3. So that's going to be about, oh, that's not right. X equals 3. So here, it's a little crooked. But eventually those lines, let me extend those maybe. Boop. And I'll go ahead and draw it here. Oh, that's a big reason why, is I'm not graphing 3, I'm graphing 5. Okay, so those intersect there. And so then what our graph ends up looking like is it goes along these lines here and along these lines up here. And then these areas are empty. Okay, so we're not worried about graphing just yet. but those are both slant asymptotes and horizontal and vertical asymptotes.